take space type of structures, give any file name like C analysis, and that file must be saved in your own folders. Length unit must be in meters, force unit must be in units. Click on next. This option may be active or can directly go to open structure wizard also. Click on finish. Now close this part because we are creating the 3D frame structures. Directly go to geometry under that run structure wizard. After that, these are some of the standard models available in Staad Pro. Select frame type of models. Under that, gray type of frame. Double click on that. Now tell me the dimensions of the structures. What is the total length of your structure? 30, correct? And how many number of bays along breadth and length? 6. Each bay length of along x-axis 5 meters. Just look at here whether equal length provided for each bay length. Next, how many number of what is total height of the structures? 51.5. Number of bays along height including plinth. 11. Huh? If it is 11 means what? That 51.5 is now divided by 11. Equally it will take, but now in our case it is not like this because typical story height we have taken 5 meters, right? So now we have to change it. We have to change that. Assume that base height is of 1.5, nothing but height of plinth. Next, all remaining typical story height is of 5 meters each. 5 meters. 5 meters. Meters. Next. Click on OK. 5 into 10, 50 plus 1.5, 51.5. Next, what is total width of the structure? In Z direction, 70. How many number of bays along width? 10. Each bay length along width is of 7. 70 by 10 gives 7 7. Click on OK. If you click apply, the whole model is created. The whole model is created. It gives your dimensions. Transfer this model to the main part of the window, to the main part of the Staad Pro. Close this. Just click on yes. Would you like to transfer or merge this prototype into the Staad Pro? Yes. With 0 coordinates of x, y, and z. Click on OK. This is the total model created. So first stage in this is your length, this is your breadth of the structures, and this is the height of the structures. Look at the directions: x length, y height, z width or breadth of the structures. Understanding? After that, this is the first stage in pre-processing mode. In pre-processing mode, we are creating the geometry of the structures. What next? The next one is to give the member properties. Member properties, without that member properties, if you skip any one of the steps in between, definitely you will get error. To avoid that error, follow steps one by one. नहीं बाद में footing का डिजाइन बाद में लास्ट में you can do the design of foundation. Go to commands for assigning member properties. First we need to add them and add the member properties in Prismatic. Click on rectangle. Decide first the dimensions of beams. What are the dimensions of beam? 0.45 depth and width 0.3. Right? Select the material as concrete. This is for all beams. Next, 0.6 I think by 0.4 dimensions of columns. Select the material as concrete. Both the properties of beams and columns we have added. Now tell me how to assign them. How to assign these properties to all these numbers? Select. Yes. Now select all the beams which are parallel to x and z. Because assume that all the beams are same dimensions.
Y.
Z. Y is along height. Y is everywhere near the columns. Okay. Select this property and select all the beams which are parallel to x and z axis. And you must see that this must be active. Assign to selected beams. Click on assign. We want to proceed. Yes. So that means that particular property of the beam is assigned to all these selected beams. After that, select the second property of columns. Select all the beams which are parallel to y-axis. All the columns have been selected now. This must be again active. Assign to all these columns. What next?
Support.
अभी और एक है ना?
वो plate thickness.
Plate thickness we have to add, right? So adding plate thickness, first we need to add the plate thickness which are coming in the structures. Select the floor in which slab are coming. So you select only these beams.
With
Ground floor height beams. Okay, so first we need to add 4 loaded plates for individual panels. Select first node of this panel, second node, third node, and fourth node. After that, transfer this added plates using this cursor to other directions like x direction and z direction. So use translation repeat command. In x direction I am transferring this plate. What are the number of steps? 1, 2, 3, 4 and 5. So number of steps are 5. What is each wavelength along x axis? What is each wavelength along x axis? 5 meter, no? 5 or 6?
5.
Because total 6 bays are there. 5. So now default step spacing is 5 meters. By default it is 5 meters. Now click on OK. Look at here. All remaining plates are there in that direction. Now we need to select all these plates in one row. Transfer these in z directions using translation repeat command. So how many number of 1, 2, 3, 4, 5, 6, 7, 8, 9. Use again translation repeat command. Select the direction, global direction, that is z. Number of steps are 9. Next, default step spacing is 7. Correct? Fish. Click on OK. Look at here. If you select any of the panel, that plate is been added. Now, what you do is go to display whole structures, go to front view, select all these plates. This is added. Transfer this in y directions now. How many number of steps in y directions? Use again translation repeat command. In y direction, number of steps are how many? Add them. Just add them from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1 is added, already added. So number of steps are, first we need to select them. Select them. select them. Y direction, number of steps are 9. Default step spacing is 5. Click on OK. Save it. What next? Look at anywhere now. The plates has been added. All the plates added. What next now? The next thing is to assign some plate thicknesses. So before that, add them. Assume that all the plates are same thicknesses, 0.175. It is 175, not 150. So assume that all the plates are made up of concrete. Add that property of plate thickness added over here. Assign to all these plates. Just click on assign to V or select the plates and assign. Finish. What next? Suppose. Go to again commands. Go to commands and go to support specifications. Assume that all the supporting points are of fixed supports. Click on add. That fixed support is added. Select this fixed support. Go to front page. Select all the bottom nodes. Close this one. Select all these bottom nodes. See in isometric view whether all the bottom node has been selected or not. After that, click on assign to selected nodes. That support specification is added at the bottom left. Next, what next after that? Loadings. Correct? Yes. Directly go to loadings. Remember, in the load cases we have to add it. First, we will add the load case. Like in previous case, we have added. Add. Next case is live load. Add. Next, we will add seismic loads like earthquake load EQ X plus. Here also earthquake is coming from 4 directions: X plus, X minus, Z plus, Z minus. So all the critical load cases you have to look at Z X plus. EQX means earthquake forces along X plus direction. That is one load case. So that load change. Here earthquake, select that earthquake seismic force. Earthquake X, change it. Similarly, now we need to add some more load cases. Load case number 4 is EQ X minus. Copy seismic add. One more is paste X or Z plus. Select that. Copy. Add that load case. Paste. Change the direction. Minus. Add. All these individual load cases we have added. Now what next? Sorry. I need to define that. Sorry. Before adding all these load cases, we have to define. Without not defining, you cannot add all these load cases. Sorry. I have to delete so whenever you are adding special type of load cases, we have to define them. Okay, first we need to define the load cases due to seismic definitions. Click on seismic definitions and add under that. So these are some of the design parameters related to seismic definitions. Now here what you have to do is first you have to decide according to which codal provisions you are designing your structures or you are analyzing your structures. whether as per Indian standard code or for any other country code. All these codal provisions are available in Staad code. Indian code is 4 year. Okay. Indian IS 1893-1984 and also 2002 and 2005 is also there. Click on this one and look at here. These are the parameters asking. What are the parameters? First parameter is what is the parameter is 0.075. Correct? Whether it is right or wrong. We are taking as per zone number 3 0.16. You have to change it. And what is the response reduction factor? R 5. And what is the importance factor? 1.5. Assuming that this building is used for commercial building like public building, hospital. But rock and soil type. If you have tested the soil where you are constructing your structures, you have to decide it based on specific value of the soil. If it is loose soil, take type 3. If it is medium type, type 2. If it is of hard or rock type data, you take type 3. Here we will take type 2 now. Okay, next. You can take other type of structure that is mandatory, that is not required, but still you have to give this. Now one more is damping ratio. For RCC elements, the damping ratio is 0.05. Okay, 5%. And here period, time period you can calculate in both the directions. Based on the dimensions which you have in both the directions, x direction and z directions. You can calculate, or it will calculate automatically later on also in the analysis part. We'll skip that part. Okay, now click on add, or if you want to generate as per the as code provisions, you can generate it. Okay, we will add as per. And what is sulfate factors? You have to take it as sulfate factor is 1 only. When you are adding any special type of fluid, there you can do combination of fluids. The factor of safety maximum 1.5. But sulfate factor is always 1 only. You can also define these here only, or you can also define in other load cases. Okay, we will take only sulfate factor here and we will close this. The other load cases we will add in this details, load case details. Okay, under this first load case is what? Dead. Sorry, we will take first earthquake. EQ. X plus. Copy. Seismic. Add. Next. Paste. X minus. Add. Next. Paste. Z plus. Add. Next. Earthquake. Z minus. Add. Then you add dead load, live load, different cases. Dead load. Next, live load. These are some of the individual load cases we have added. One by one now we have to define the directions. In this only we have to only decide the directions. So here click on add. Under this seismic load, what is the accumulated forces, go to seismic loads. Here we have to first define the direction of earthquake forces along the x-axis with a factor of +1. Add it. Next, go to EQX minus, add under seismic loads. Here x is the only direction, but factor is taken as minus in the direction of factor. Add it. Next, under this EQZ plus, add seismic loads in z direction with a factor of 1. add that. Next, EQZ minus, add seismic loads. Z direction with a minus 1 factor. Click on. Now we need to define the dead load, live loads separately. Tell me, what is the first load? Can you calculate that? Slab load intensity, wall load intensity, partition wall load intensity, parapet wall intensity. Do that part. नहीं है? Hello sir. कैलकुलेट करके ही करना है. Approximately I am taking minus 28. Add that. Next, partition wall. I am adding some of the dead load cases here. Minus intensity of partition wall. 11.375. Shall we take 12? Approximately we will take 12. Add that. Next, tell me partition.
Partition का 11.
Sorry, parapet. Parapet का depends on the height and assume that it is of 150.
0.5. 0.68
1 meter. 1 meter. 2.5 minus 2.5 and add that. Any other dead load? First we'll assign these flow. After that we'll add 4. So this is wall thickness. Select the different beams where the walls are coming. These are the different beams where the wall is coming. On the plain beam wall is coming, and on the other beams also the wall is coming. Select only the beams now, don't select the columns. The wall load is not coming on the top floor beams. So select only these beams and then go to low beam, new beam, okay, go to plan. Now you are in plan mode. So select this external wall where the beam load is coming on it. Click on this. Select all these beams. Assume that on these beams the external wall load is coming. Assign to selected beams. Look at an isometric view. Next, select this one. Select all the other beams except the exterior beams. Drag a rectangle like this. All the other beams have been selected. Assign this partition wall loads. Assign the selected beams. Assign. Next, this is on all parapet top floor beams. Go to display all structures. Display only the top story beams. Select these beams using new view option. Go to plan. Select all these periphery of top floor beams where the parapet wall is coming. Select, assign selected beams, assign it. Okay, look at here. At the end, the parapet wall is added. Suppose if there is any opening in between, that particular opening is also having parapet walls in between. अगर नहीं है तो you can leave that. After that, close this. Go to display all structures. Now, under this dead load case only, we have to add. What is to be added? with dead load of slab and flow finish together. सल्फेट भी ऐड करना है इसमें, सल्फेट भी ऐड करना है.
Slab का 4.3
4 point dead load and flow finish both minus 6 minus 6 kilonewton per meter square. Let us take approximately, and here we have to define the heights. What are the heights? What are the ranges now? Y, X and Z. Minimum Y is taken from the plinth, above the plinth level. So it is from 1.5 to till top floor level. 51.5. Next, minimum X 0, maximum X. Maximum X 30. Minimum Z 0, maximum Z 70. And then okay, next up, live load intensity. Under live load, we need to add another sulfate slab. Flow loads minus 5 varying, right? Same ranges 1.5 to 51.5 range. Minimum X 0, maximum 30. Minimum Z 0, maximum Z 70. And that globally in y directions. I think here slab will not come at the plinth level. Slab will not come at plinth level. So what you have to do changes here? See, the slab is also added at plinth level. It is not correct. You have to skip that. So double click on this, change it. 1.5 make it as 1.6. If you do that change, you will see the changes. The plinth level slab is not added. Similarly, double click on this. Instead of 1.5 height, you take it as 1.6. Click on change. After that, what next? These are the different individual loads we have added. After that, we need to do load combinations. So for that, go to new, load cases, combination of loads, and let us take auto generation of loads as per Indian standard, that is as per Indian code. Okay, generate. If you click on generate, it will generate as per the standard table of load combinations. Earlier, how many load cases we have added? Only 6. Now you will see how many number of load cases. Total 27. And that. Okay. Now go to commands, analysis, perform analysis. Okay. Next, print, post analysis print, analysis result, add that command, analyze it. These are the number of steps to be carried out in pre-processing mode. Go to output or directly go to the results. No errors. You can see this output result. Join displacements at join number 1 due to all load cases. Only at join number 1 due to all load cases. How many number of load cases we have added? Total 27. Can you see that? Total 33. 27 plus that 6, 33. Similarly, for node number 2, what is joint displacement? Again, due to all load cases. Like that, for all the nodes, it will calculate. Now, we will see directly the results one by one. Go to animations. Due to earthquake force along x-axis, deflections will change the scale factor from 1000 to 110 like that, or 1:20, so that you can see the displacement diagram very clearly. Apply. Morning mode. Fine. Here, these are the seismic forces acting in x plus directions. Look at, when you go to higher story level, the wind forces acting at that level is higher compared to at the bottom level. Similarly, if you click on x minus, it is in these directions. Z plus from the other directions. From the other directions. In left side you can see. And Z minus, look at it. The seismic forces acting, that is the formula of Q is there. What is Q is there? Q is used to calculate design lateral forces due to earthquake at individual floor level. And dead load cases we have added, live load cases also we have added. Animations. Due to dead loads, the structure is dancing. Only due to dead load cases. Look at the load cases at the top. Next, live load. Here the reflection is very less. Why? The intensity of live load is very much less. Similarly, now we look at the other load cases. Earthquake load, when it comes in x positive directions, how it behaves? It goes towards right directions. Similarly, in other directions. Next, Z plus in other directions. Next, Z minus. After that, we can see some of the load combinations. This is the combination of the 7 load cases. What? The combination of dead load plus live load with factor of safety 1.5. The other load combinations are with ये बहुत important है. ये जो animation part है, this is, you can see the behavior of your structures, how the structure responds during the earthquake forces. So after that, you can close this part. And you can also see the reflection. Section displacement and reflection. And if you want to see the idea, this is how your structure responds during the earthquake process. This is the maximum displacement it takes place. Summary of displacements. How much summary you will get for displacement values in all directions. These are the critical load cases for different critical load combinations. What are the need? Parameters to study. What is maximum displacement? Can you see that in the certain columns? Which is the highest value? 71.01 810. Sorry, it is at joint number 240. Compared to all the joints, the load cases. Okay, so this is how you can study the analysis part of your structures in different directions. Look at for different load cases. For dead load, live load, this is actual, huh? Next, load combination, dead load and live load, other load combinations. In different directions, you can see the displacements. And the structure is designed always for the critical load combinations. Whichever is the critical load combinations, as per that, the structure is always designed. Again, now apart from this deformed shape of the structures, we can also look at the other diagrams like shear force and bending moment. You close this part. Look at shear force diagrams. Due to again all load cases, due to dead load, due to live load, or due to combination of dead load and live loads. Similarly, close this icon for shear force and open that bending moment diagram icon. Due to again different load cases. Now I will tell you one more thing here. If I want to see clearly, the bending moment diagram and shear force diagram for individual members, double click on any of the members. Suppose if I want to look at the nature of bending moment diagram for this particular member, double click on this. It will show the details of that particular selected members. Like what is the geometry of that selected member? What is the length of that member? 5 meters. What is the depth of that member? It is a beam, 0.45 meters. And you can also look at the properties, sectional properties of that beam. 5 meters, 0.45 meters and 0.3 meters. Next, loading applied on it and shear and bending. And also the deflection values. How much displacement occurs in that particular members. Look at here. This is for bending and this is for shear. Deflection values. Even you can click some other, you can see the details. Beam, geometry, properties, loading applied on it, shear and bending, deflection values. Only due to what? Arctic load cases is. Similarly, due to other load cases, what? Dead load plus live load plus 1.5. Double click on it. Shear and bending. Another load case of 1.5 dead load plus live load. How it bends? It bends in this shape. The beam fails in bending in this direction. E diagrams का तुम print out लेना exam में. You have to take the printout of loading diagram. You have to take the printout of displacement diagram. You have to take the printout of shear force diagram, bending diagram. If it is only analysis part, or a class I will take on design part, how to design the elements using Staad, like beam.